Okay, we're discussing experiment 39, electromagnetic induction. This is, I've provided you with the uh, paperwork for doing experiment 39. Unfortunately, it's not a very good uh, reproduction, but it's the only thing I've had. I've inserted some latex equations to maybe help you see better. First off, you want to make sure and do the advanced study assignment. I think there's about 5 questions. Do those. I encourage you to read the theory. I'll go through the theory a little bit myself. First of all, we know that um, if you have a current in a wire, if this is the direction of the current, we'll take it to the point of my Apple Pencil as the current direction. We have current in this direction. You have a magnetic field that wraps around the current, the conductor, and it's shown right here. This is the magnetic field. There, if you see the crosshairs, uh, that's the tail end of the uh, current. You think of it like the flexings of an arrow. So it's going into the screen, and that's why it's wrapped around that way. So here they discuss the right hand rule for uh, determining the direction of the magnetic field in the uh, current carrying conductor. Let's talk about the magnetic flux. Magnetic flux P is equal to B dot A, dot product. If you're not familiar with the dot product, it simplifies to just BA cosine theta, where uh, the theta is made between the normal to the plane of the plane that you're looking at, the normal to the plane, and the magnetic field. So if the magnetic field were going this way, then your normal would be over here, and it's the angle between the magnetic field and the normal to the plane. That's where the theta comes from. Uh, so theta, phi equals BA cosine theta. Uh, the uh, EMF is equal to minus the um, delta phi delta t. What that tells us something, that it says that E will only occur if there's a changing magnetic field, a changing flux, a change in flux. Well, the change in flux can come from 3 different. Oops, let me get rid of this. Didn't notice that was there. Let's see if we can get rid of that. Delete. There we go. Um, this is the equation. Um, delta phi over delta t. It can be expanded. I have a little better copy of it down here. Um, delta phi, delta t. Let's see how big I can make this without losing it on the screen. So delta v over delta t, if we expand that, you can see you can have delta b over delta t times a cosine theta, or you can have b times delta a over delta t times cosine theta, or you can have ba times delta cosine theta over delta t. And what does this mean? Well, in this portion, you get delta B over delta T means you have a changing magnetic field. And that's the one that we're going to be applying today, where we have, as we insert a magnet into a coil of wire, uh, you've got a growing magnetic field or a collapsing magnetic field. So delta B over delta T means a changing magnetic field. You can have a changing area. If you were to take your coil and somehow change the area, somehow collapse it or deform it, you would have a changing area, or you can have a changing phi. If we have a magnetic field in this way, if we were to rotate this, it would be a changing theta, and that would induce a EMF. And so those are the three ways that you can have delta phi over delta t. changing magnetic field, changing area, or changing angle. So let's collapse this back. Let's see if there's anything else that's important that we need to talk about. So we're going to set up experiments, and I've already got them recorded for you. We will be inserting a magnet into a magnetic field, and we're going to see a deflection. And you're going to see as I'm putting the magnet in, it's a growing magnetic field, so it's going to produce a magnetic field that opposes the growing magnetic field. As I withdraw the magnetic field, it's going to want to reinforce that magnetic field, and so we'll get the opposite deflection. Now, I use some small magnets on some of these, so we're going to, let's see, I don't have much up here. Let me just say this is this battery. We can use this as the north and this is the south. As I insert it, you can see you have a growing north, so it's going to oppose it, but all of a sudden you have a collapsing south, so it's going to want to reinforce that collapsing south. So you'll get an opposition to the growing north, but then you'll get another opposition to the decaying south. And of course, as we pull it back through, you'll have the opposite sex, the opposite effect. So you'll see the needle deflecting back and forth. And then we're going to do, we're going to use long solenoids, but we'll see one is just powered up to the coil and the other one is powered up to the meter. And as we insert the magnet, we're inducing a current, and here the current here will be creating a magnetic field. So actually that's going to be done electronically, not using a magnet. We're just going to, it's going to basically making this one an electromagnet, and this electromagnet is going to induce a current in the secondary. So those are all things that we're going to do using. This was done in the lab, so I have some of this equipment. It's not stuff I'm doing at home. And what we're going to notice is as we turn the electromagnet on and off, it's going to vary depending on whether we're using an air core or whether we're using an iron core. And those are the only cores that we have, just the air core and using an iron core. And then I'll provide you with some of the data that I read. They ask you to do a couple of sketches. I think we want to, there's a plot that you need to produce based on this data. Oh, that's the one where let's see, I don't have anything that, we're gonna have two coils and we're gonna separate the coils little by little and look at the reading from that. And then you're gonna answer the questions. This question one, I especially want you to answer parts A and B. We've already covered some of this in when we discussed motional EMF. And it's only 3 questions, 1, 2, and 3. Of course, there's 2 parts to question 1. And so that's going to serve as our introduction to experiment 39.